welcome to geology. So if I were to ask you, I'm going to just use this little line right here as a stand-in. If I were to ask you, where would on this line would you put dinosaurs? If I were to say that the Earth formed here, building off what we did in the last video with the formation of Earth, and today is over here, where would you guess the dinosaurs are? Do it in your head right now. And historically, when I've asked that question, people put them way back here somewhere, saying, "Oh, dinosaurs, that was a long time ago." And it was a long time ago, but like it says right here, if you're in our chapter, geological time is vast. The amount of time that's passed is continually mind-blowing to me, and I've been elbow deep in it for a long time now. There's always new ways that I've seen it represented that are kind of eye-opening in another way. So creating these timescales, and if you're in my lab, you had to create a timescale. Models of these timescales is kind of like every book you get does it in some different way, right? Like if the Earth were a 24-hour day, when would humans show up? When would the dinosaurs be? Things like that. I like this one because it shows the giant Precambrian. So here's what I have my high school students do, and you may have done this in high school. With cash register ticker tape, you make a timeline. I'll make this big so it shows up a little bit, of the Earth. So what happens, and we're very overexposed here. I don't know if this light will help. I guess the light doesn't want to turn on. But if you can see at least that much, we've got a section in yellow right here, Cenozoic. We've got a section in red right here, the Mesozoic. There's your dinosaurs. And we got a section back here, the Paleozoic. There's your more primitive life, trilobites and those little guys creeping around. So there is kind of the whole history of advanced life. Yes, there was very simple life back here, but when we get into the Precambrian and what happened before that, you're going to see how long it is. And even charts like this are misleading in a way, because what this does is it says, and this there's a link to this that's broken in the textbook, so I'll post this in there. What this does is say, okay, here's your Paleozoic, all of that light green, Mesozoic's that blue, and Cenozoic's that yellow, and everything before that is that pink. But here's the thing, that pink section there is 88% of Earth's history. So on our timeline, there's those last three eras, and then the rest is like a ridiculously long amount of paper. On this ticker tape, every millimeter represents 1,000,000 years. So we've got a lot of time that passes before we get up. I'm just gonna get rid of this. Before we get up to Paleozoic, Mesozoic, and Cenozoic eras. Now, this chart is not trying to lie. It says it right over here, that the Earth formed 4,600 million years ago. And this Precambrian time then goes up to about 538 or so. There's 88% of Earth's history. The last 12%, they flesh out a little bit more. The rocks that are more recently formed, we've got kind of better resolution on. They've been less beat up by the rock cycle. We've got the evolution of life providing us with the divisions that we invented to divide up time here based on either geologic events or history of life events. Okay. Now, if this thing looks intimidating and you're saying, "Oh man, this looks like a lot," don't worry. First off, you can use it and refer to it. Second, you want to get down to like stages and ages at all in this course. What you probably want to start to get familiar with are, say, certainly the last two columns on the left of each one of these. So the eons or eras. If you can just start to like wrap your head around that and look for other models of what those look like. If you are getting into geology and you want to start to get ready, you're going to want to know the periods too. I'm not going to put that in this course as like a memorization thing, but it'll happen soon. So you might as well start. Stick it in your head. Our book does a pretty good job with this of saying, here's the eons. And again, 88% of Earth's history, then those three eras that we just talked about. And then here they break that down and make it larger. That within the Phanerozoic, those three eras, Paleozoic, Mesozoic, Cenozoic. So there's our timeline. Back here, with that line. Where did you guess dinosaurs? Because this one's done from there to there. Dinosaurs are in that blue chunk right there. They're very recent. Humans are such a negligibly small little edge on the ends that it's impossible to write on the scale that I have this, that I have them do this. They're supposed to write in this lab earliest humans down here at the ends. But even like writing a letter is too big on that scale to say how long ago humans would have been here. You need a microscopic pencil. All right. And again, there we go. This actually, that's great. That breaks down the Cenozoic then into where we go for getting towards us. Okay. So check that out. The history of life is long, deep, and vast. And the discovery of all of this was the big leap that basically allowed geology to be a science. The idea that there was times where we would assume that the Earth was pretty young and put here for humans, right? Now that we've gotten a little deeper in this and read this little section here on Hutton, it was the leap that was needed for geology to exist, to realize that the missing factor and how rocks got there, how rocks look the way they do, is an immense amount of time. So what we'll do, I tried to do this all as one long video and it turned into a mess. So I'm going to stop there and then do separate ones for relative dating and a separate one for absolute dating. Because how do we know? That's what we got to do. How have we figured out all of this stuff, all of these timelines? There's different techniques to get there. And the big differences are going to be relative dating is going to be saying that this thing's older than the other thing. There's techniques to say which rock would be older than another rock. We'll go through all of those in a video. But that doesn't give you any numbers. That just says that this rock's older than this rock. We don't know how old, just older. So then you bring in the other one, which is absolute dating. That'll be down here, which will be, it's down here somewhere. There we go. That will be putting numbers on it to say, okay, here's exactly how old the rock is. Then you can combine them, because if you know how old one is in one instance and know that another one's younger than that, you can start to really develop a book of the whole entire history of the planet, which is great. So look for those videos next. We'll talk to you guys soon. Take care.